Every device you use today, your phone, your laptop, the server streaming this video, traces its ancestry back to a shed in the English countryside in 1943. And the reason that she'd existed at all? Hitler needed his generals to keep secrets. We talk about Alan Turing constantly in tech circles. His name is on awards, on biopics, on t-shirts, but most people don't know the actual chain of events that forced him, and a team of brilliant misfits, to invent the computer. Not as a thought experiment, as a weapon. And the machine they built to break Nazi encryption is the direct ancestor of every processor on the planet. Here's what actually happened. The Enigma machine looked like a fancy typewriter. The Germans used it to encrypt every military communication, troop movements, U-boat positions, attack coordinates. You'd type a letter, and through a series of rotating scrambler disks called rotors, plus a plug board with cross-wired cables, the machine would output a completely different letter. The genius of it, the encryption changed with every single key press. Type the letter A twice in a row, and you'd get two completely different cipher letters out. By 1939, the German military version had 3 rotors chosen from a set of 5, a reflector, and a plug board with up to 10 cable pairs. The total number of possible settings? Around 158 quintillion. That's 158 followed by 18 zeros. The Germans were convinced it was mathematically unbreakable. Their own cryptographers had checked the math. They were right. By hand, it was unbreakable. Winston Churchill called them the geese that laid the golden eggs and never cackled. They were housed in a Victorian mansion called Bletchley Park in Buckinghamshire. Deliberately unremarkable, deliberately isolated. The team was recruited through crossword puzzles. Literally. The Daily Telegraph ran a timed crossword challenge. The fastest solvers got a mysterious letter inviting them to a government job they couldn't discuss with anyone. What they assembled was extraordinary. Chess grandmasters, linguists, mathematicians, classicists. Alan Turing was already famous in mathematical circles for a 1936 paper, describing a theoretical machine that could execute any computation if given the right instructions. He'd called it the universal computing machine. It was purely theoretical. No one had built it. Bletchley was about to change that, but before Turing could do anything, the team needed a head start. Polish mathematicians Marian Rejewski, Jerzy Różycki, and Henryk Zygalski had actually cracked earlier versions of Enigma in the 1930s. When Germany invaded Poland in 1939, they handed everything they knew to the British. That handoff is one of the most underappreciated moments in the history of computing. Turing's core insight was this: you don't need to find the right settings from scratch. You need to find a contradiction. If you can guess that a specific piece of ciphertext contains a known phrase, like a weather report that always started with the German word Wetter, you can test that assumption mechanically and eliminate wrong settings faster than any human ever could. He designed a machine to do exactly that. The Bombe, named after an earlier Polish device called the Bombe, was an electromechanical computer roughly the size of a large wardrobe. By 1943, Bletchley had over 200 of them running in parallel. Each bomb tested settings at a rate no human cryptanalyst could match. They weren't general-purpose computers. They did one thing, breaking Enigma. But the principle, using a machine to perform systematic logical operations, was genuinely new. Gordon Welchman, a mathematician who improved the bomb's efficiency dramatically, later wrote that the work created the basic concepts of modern computing. He knew. He was there. Enigma wasn't the only cipher the Nazis used. Hitler's high command communicated using an even more complex system called the Lorenz cipher, codenamed Tunny by the British. The Lorenz had no manual typewriter input. It teletype printed encrypted messages automatically. It was used for the highest level communications, including between Hitler and his field marshals. Breaking Lorenz required something the bomb couldn't do. It needed a machine that could read patterns in data, adapt its logic, and process at electronic speeds. A British engineer named Tommy Flowers built it. He called it Colossus. Colossus, completed in 1943 and expanded in 1944, is the world's first programmable electronic computer. It used yet 500 vacuum tubes. It could read punch tape at 5,000 characters per second. And crucially, it could be reprogrammed. Change the switches and plugs, and you change its behavior without rewiring the whole machine. That's the distinction that matters. Not just a machine that computes, but a machine that can be told what to compute. 10 Colossi were built before the war ended. Then Churchill ordered them all destroyed, every single one. Blueprints burned. The people who built them signed the Official Secrets Act and couldn't breathe a word for 3 decades. Because Bletchley was classified until 1974, credit for inventing the electronic computer went elsewhere. ENIAC, built in the US in 1945, got called the first electronic computer in most textbooks, because nobody outside of a handful of cleared officials knew Colossus existed. By the time the truth came out, the narrative had hardened into history. Turing himself never got to tell any of it. He was prosecuted in 1952 for being gay, a crime in Britain at the time, chemically castrated by court order, and died in 1954 at age 41. A royal pardon came in 2013. His face appeared on the British $50 note in 2021. Cold comfort, 6 decades late. The ideas survived, even if the machines didn't. John von Neumann, one of the architects of ENIAC, was briefed on aspects of the British work. The von Neumann architecture that every modern CPU still uses, with its separation of memory and processing, echoes principles Turing had already worked through on paper. Whether von Neumann absorbed those ideas directly or arrived at them independently is genuinely debated by historians. But the parallels aren't coincidental. Here's what I think most people miss about this story. We frame it as a war story. Nazis, codes, heroes. But it's actually a story about what happens when survival forces you to solve problems no one would ever rationally fund. No committee would have approved a budget for a theoretical computing machine in 1939. Turing's 1936 paper was academic curiosity, interesting, publishable, fundable as a thought experiment. The return on investment was invisible, but when the alternative was losing a war, suddenly you build 200 bombs. Suddenly you build Colossus. Suddenly the impossible gets done in 18 months. We are in an almost identical situation right now with AI. The scale of investment happening in AI research today is driven not by rational market forecasting, but by existential competition between companies, between nations. OpenAI, Anthropic, DeepSeek, Google DeepMind. They are all in their own way, Bletchley Parks racing against each other. And here is the uncomfortable part. Just like Bletchley, a significant portion of the most consequential AI work happening today is classified. Military AI programs, signals intelligence automation, autonomous targeting systems. We will probably find out what was actually built somewhere in the 2050s, the same way the world found out about Colossus in the 1970s. History is running the same playbook, just compressed in time. The Nazi Cipher machine didn't just help win a war, it bootstrapped an entire technological civilization under the pressure of annihilation, which raises a question worth sitting with. What are we bootstrapping right now, and will we even be allowed to know? So, next time you unlock your phone with your face or ask an AI to draft your emails, remember, that chain traces back to a secret shed, a wartime machine, and people who couldn't tell anyone what they'd built. If that's the kind of history that actually matters to you, the subscribe button is right there. Next video,